Data and databases. What is data? Data are raw bits of information with no context. Malignant stage 4 convulsions. What are you saying? Without context, data remains as data and cannot be used and understood. Data can be one of two things: qualitative, any data that is used to describe or give description; or quantitative, any data that is in numeric form or anything that indicates quantity. Data needs context to be useful. Data plus context would be information. Information is processed data which can be used to understand and describe anything. How about knowledge? To better use information, it must be aggregated and analyzed. Aggregated and analyzed information is called knowledge. What about wisdom? Wisdom is the combination of knowledge and experience developed through time. Let's take a look at the information ladder. Here are the examples of data. So now, let's proceed to database. What is a database? A database is an organized collection of interrelated data. Databases come in various forms, but the most popular is the relational database. In relational databases, data is organized in tables, comprised of columns, also known as fields, and rows, also known as records. Here is a sample table. Columns or fields. The rows are the records. Some popular relational databases includes MySQL, Microsoft Access, and Oracle. Now let's proceed to designing a database. In relational database, all tables are related by one or more fields known as primary keys. Designing a database sounds hard. Then, let me walk you through how a database is designed. Designing a database. Let's try making a database for a school. Look at the steps above. First, identify which entities we will be storing data of. This can be students, clubs, and events. These entities will be represented by tables. Second, identify the data we want to store about each entity. For students, we can store their names, email, and year of birth. For clubs, we can store their name, president, and a short description about them. For events, We can store their name, date, and number of attendance. The tables should now look like this. For events, for students, and for clubs. Since this is a relational database, we need to determine the relationship between the tables. Relationships. One-to-one. One record in a table is associated with one and only one record in another table. Let's take a look at this example of table for parent and child. Trivia. In 1980, China implemented one-child policy. Parents can only have one child due to overpopulation. One-to-many. One record in a table can be associated with multiple records in another table. Let's take a look at this example of tables for the events and clubs. A club can hold many events, but an event can only be held by one club. Many-to-many. Multiple records in a table are associated with multiple records in another table. Let's take a look at this example of table for students and clubs. A student can be a member of multiple clubs, and a club can have multiple members. Many-to-many relationships are not as simple as the other two relationships. We need to use another table called a join. Here is an example of a join table. Let's proceed to primary keys. By definition, a primary key is a unique identifier for each record in the table. Cannot be modified, can be a student's ID number, employee number, or anything as long as it is unique and unchanging. Notice the IDs on our tables. For events, students, and clubs. Note, a primary key is usually named simply ID. Now, how can we relate these tables? Join tables. So join tables or pivot tables are tables which contain the primary keys of the tables it relates. Join tables are used to establish many-to-many relationships. Let's take a look at this example of tables. Our tables should now look like this. In the next lesson, We will learn about normalization. Normalization. Hi, Marge here. I'm here to discuss about normalization and data types. In simple terms, normalization is the process of reducing the duplication of data between tables. It gives the table as much flexibility as possible. For example, in our database, we could have simply made a members field in the club's table to hold the list of names of its members. See the table below. But this would mean that we have to enter the data of students twice, one for the students table and another for the members field in the club table. See the table below. Another instance is not very obvious, but the name field in the students table should also be normalized. See the table below. For more flexibility, the name field should be divided into last name, first name, and middle name fields. See the table below. Now that the last names, first names, and middle names of students are separated, sorting students by their last, first, or middle names is possible. See the following sample students and club tables. Now, let's see the memberships table. Can you see who joined which clubs? Student 1 joined two clubs, 1 and 3. Student 2 joined club 1. Student 3 joined club 2. Student 4 joined club 2 as well. See how convenient join tables are? Now let's proceed to data types. Quite literally, data types are types of data we enter in our database. Some of the most common data types will be listed here, so pay attention. Integer, text, Boolean, and date time. Integer, for exact numeric data like for example 1, 2, 523. Integer usually used for IDs or as primary keys. Text, for words, phrases, or sentences. Text can be a combination of numbers, letters, and symbols. Boolean, for yes or no data, true or false. The database uses tinyInt as its data type and interprets 0 as false and true otherwise. Datetime stores data related to date and time. Date time used for registration dates, last login, and etc. But why use data types? Data types tell the database what operations can be done to certain data. Data types help the database decide how much memory to allocate to a certain data. Structured query language. What is structured query language? Structured query language is a standard language used to communicate with databases. It's used to store, modify, and retrieve data from a database. Let's use the following students table for our example. The question is, how can I get the first and last names of those born after 1995? We can use SQL to make a query from the database. Try to look into the query below. The query below will return the following result. Let's break down the query below. Select is a command for retrieving data from the database. With select, we can specify which fields we want to retrieve, like for example, first name and last name. From is a command for specifying which table or tables will be used. From is usually used in combination with select, delete, update, and insert into. Where is a command for filtering your query result. It uses Boolean statements to check whether a record satisfies that condition. In this case, we filter the results by only getting the first and last names of those whose birth year are greater than 1995. Let's try inserting a record into our students table. Let's look at our students table. Let's try the following line of SQL commands. Try to look into the query below. Don't be intimidated. Let's break it down and analyze. Insert into is a command for adding a record into the database. All it needs is the name of the table and the fields which we will fill out. Take note, fields are enclosed in parentheses and separated by commas. Values. Values specifies the exact values that will be inserted into our database. Take note that values must follow the same order in which the fields are arranged before the values command. Our students table should now look like this. Let's try updating a record into our students table. Consider the following SQL commands. Update is a command used for modifying records in a database. After the update command is the table being modified. Set. Set is a command used to set the value of a field. In here, we are setting the value of middle name into Bello. We only want to update the record or records which has Joy as the first name. Our modified table should now look like this. Now, let's try deleting a record from the students table. Consider the following SQL commands. Delete erases a record or records from the database. From specifies from which table a record will be erased. Where specifies the condition for filtering which records will be affected. In this case, we want to erase the records of students who were born on 1992. The students table should now look like this. There are no more records on students born in 1992. That's it for our sequel lessons. Bye for now.